All right, I've called it an optional example because I think this example maybe falls a little bit outside of the bounds of what I usually put on homework questions corresponding to this chapter, but nevertheless, it might be worth considering. So we're looking at a car that is slowing down while it's moving in a circle. So maybe let me draw a little picture of that here, or an attempt at some sketch. So I'm going to maybe draw the pseudo-circular trajectory here for it and say, okay, here's the car doing this thing. I'm just going to draw it as a box. I guess I drew it right over that trajectory there. Maybe just for fun, I'll put some, it's like a toy car. Maybe the way I'm drawing it, if there are wheels sticking out like that. I don't know, do real cars have that? Maybe it's a new style, right? Anyways, but we're thinking about this car. It's at some instance where it has a velocity v, but it's slowing down, so there's definitely a acceleration that is the tangential component of acceleration. But since the car is going in a circle, there's definitely at the same time a centripetal component of acceleration. And in that sense, if I say like, well, what is the overall acceleration, should be a vector that kind of, I don't know, points at some, I don't know if I got the angle right there, but the basic picture of this is like that acceleration vector is the vector sum of the centripetal acceleration and the tangential acceleration vectors that are shown in my sketch here. Now, the tangential acceleration vector's magnitude is simply given to us as 5 meters per second squared at 3 sig figs, but I'm just going to abbreviate it here. I think we have to calculate the centripetal acceleration vector using v squared over r. And since we're looking at an instant here where the car's velocity is equal to 15 meters per second, we're looking at doing that squared divided by 35 meters squared, since that's the radius that was given to us. So that, I'm going to go turn to my calculator now to get a number for that. It's kind of an intermediate result here. Let me see. I think I'll report that. I've got like 6.42857, etc. But let me see. Maybe we want 3 sig figs, so let me go 2 more. I'm going to go to 8.6 here is probably good enough. That's 2 more than I know I'm going to wind up with. And it looks like everything works out there for meters per second squared, just checking to make sure everything made sense. And then based on this picture right here, I know that the overall acceleration, oh, and I accidentally left up the answer on this slide as I started this video. Whoops, well, we'll keep going. We're going to get to see if we're going to get to that, but here's how you get to that. You want to do the square root of the centripetal acceleration squared plus the tangential acceleration squared. So in my calculator, I'm going to input 6.4286 meters per second squared plus the 5 meters per second squared, also squared. And my calculator says that that's like 8.144, etc. But clearly that agrees with the answer we already see presented there, since I accidentally left it up, of 8.14 meters per second squared.